Hello, it's Tuesday morning and I'm at the bus stop. So I'll be in late as I am usually on Tuesdays, and I'd like you to watch this, take notes, and observe an example and be on your way in regards to the assignment. So title your note area Average Value. So we're going to look at an average value over a certain interval. So let's draw ourselves a curve. Okay, so we have a continuous curve and we're interested in the average value on a certain interval. So we're going to look for the average value on a closed interval AB. So we're only interested in the curve from here to here. Let me make the curve a little more dramatic. So we'll have it dip down and then go back up, something like that. So I'm only interested in the curve from here to here in this area between A and B. And I was wondering what the average value was. So every single point, the infinite number of points along here have a value that's read over here on the y-axis. Like here's a low value, here's a high value, here's lots of values in between. But which one is the average value? And another way we can think of average value is what is the average height of this function? So from here to here, and of course we read that height over there. So it's just another way of saying the same thing and thinking of it slightly differently. So what is the average height? What is the average height of this function on that interval? So let's just talk about that. Let's say that we're going to find some height, and let's say the average value, let's see, it goes up, it goes down, it goes way down, not as far up, then it goes up. I don't know, say this is the average value right there. Total guess, but all right, so notice if that's the average value, then if I make a box where the height of the box on the interval A to B is the height of the average value, so I have a rectangle, I have now established a area. So length times width, and here we have a height times width. So I'm going to observe the height times the width that I've marked here, striped with stripes. I want that to be such a way that it is equal to the whole area under the curve from A to B, which we know is the integral. So that's the kind of relationship the average value establishes. So with that in mind, I can develop a formula because the height, what is the average height? That is that height right there that I'm talking about, so that when you multiply it by the width, you get the integral of the area under the curve. That height is the average value. And it will behave like this. It will follow this formula. So we have average value times what's the width? Well, the width in this case, in every case, is b minus a, the endpoints of the interval, and then that equals the integral of the function. All right, so putting that, so we've kind of taken words and put them in mathese. Let's call it average value. I'll indicate it. You can leave it as average value as the function's average. Now we're totally in mathese. All right, so since this lesson is looking for the average value, the function's average point, we can just solve this equation. Function's average equals, if we move this over here by division, it can pop up like that, times the integral f of x dx. And actually, that's all there is to it. That is our formula for the average height of the function, or the average value of the function. So there it is. So write that down, and all we need to do is an example, and your assignment will be like those. So let's do an example. I'll leave the formula in the screen, and we'll zoom. Let's find the function's average on 0, 3, and the function that we're going to study, practice this on, is f of x equals x squared plus 1. So find the function's average on 0, 3, and the function is x squared plus 1. I like to always draw a picture of it. So in this one, we have the smiler, the parabola that opens up, and it's raised up 1. So about like that. And we're interested in this between 0 and 3. So here is the function. Actually, we're not really interested in this stuff exactly. Here's the function. It starts here and it ends there, right along that. And I want the average value along that line. So, using the formula, I think it's still into view. It's going to be 1 over b minus a, 1 over 3 minus 0, times the integral from 0 to 3 of the function, x squared plus 1 dx. Alright, so in integral land we go, and we get 1/3 x cubed over 3, the integral of 1 is x, and we evaluate that between 3 and 0, and then just a little cranking. 3 cubed is 27 over 3, and then we subtract. When we put in the 0, we're just going to get 0. So we end up with 1/3. 27 and 3 is 9/3. 27 and 9 are 36. 36 thirds. So multiplying, we get 36 over 9, or 4. Okay, our answers aren't always whole numbers, but this one is. So this is saying the average height of this function between here and here, like this point is 0, 1, and this point is 3, we put in a 9, 10, 3, 10. So from here to here, the average height is 4. So it went from 1 to 10 in a curved fashion, and the average height is 10. So, I mean, the average height is 4. So if this is 10, then this is 1. We've got a 4 somewhere about right there. So that's going to be the average height. So sometimes your text also asks for another question. Not only does it ask for the 4, which in our picture would be right there, the average height, but it also says find the values for x which equal this height. So all we have to do is take our answers. This is the average height was 4, so if we have f of x equals x squared plus 1, which we can think of as y equals x squared plus 1. That 4 is the height, it's the y value. So they're asking you for the corresponding x values. So solving this, you move the 1 over, take the square root. And recall, when you take the square root of both sides, you get a plus and a minus. So the only thing is, when you do that, in our question, in our scenario, are both mathematically, this equation does have these as its answers, but do they make sense for us? Could the negative root, the square root of 3, be included in our answer? And no, it cannot, because we have only identified x's from 0 to 3. So therefore, we can drop the negative 1. And we only have the positive square root of 3 to answer that question. All right, so let's see what I would have for you to do. Let's try 4.4, and I'm not sure what page it is, but go to section in your book 4.4, numbers 51 to 56, and that will give you all the practice you need in finding the average value. Okay, see you soon. Bye.